This is lecture 14. This is continuation from 13. Not much in here. What we really want to do is take a look at the load type instructions in a timing diagram form. So essentially be looking at that primarily in an example. Other thing we want to tuck in there is the notion of comparisons. We certainly have a bunch of branch instructions that will compare things and branch accordingly, but two comments on that. Maybe we want to make it compare or not branch, and also maybe we want to make it compare with something other than two registers, so more on that later. So what we want to take a look at is that load instruction. The load instruction is, the load type instructions are one of the instructions that take 3 clock cycles. So there's 5 instructions essentially that require 3 clock cycles. And those instructions are the load type instructions, which are right here. Get a couple flavors for bytes, half words, and words, and unsigned and signed, etc., etc. So most of our instructions are comprised of a fetch cycle and execute cycle. We have the load type instructions that also have a write back cycle. Now we kind of spoke of this before in that essentially what the reason we have this write back cycle is because the memory reads are synchronous, which means essentially we have to calculate an address, an effective address out of the base address and the offset, which is something we have to use the ALU for. Once we get that, we're going to use that address to actually access a memory location, and that is going to require another extra clock cycle on this thing. So once again, timing issues are really complicated here, but they're not really. Once you get used to it, it's really doable, and you got to work with it though. And particularly, this is kind of in support of experiment 5, which means you have to understand a bunch of this stuff and get it implemented in state machine form. So let's take a look at this. Not much really going on here. You've seen this before. Most of our instructions require 2 clock cycles, and we break that. It's controlled by a state machine, so we break those 2 clock cycles into a fetch state and execute state. Or, we call them fetch cycle and execute cycle. So they go by various names. But here is the basic state diagram here. And essentially most of our instructions are going to be fetch and execute. Transition to fetch to execute is unconditional. And that execute, you have a choice. If that is a load instruction, it goes into this third state here, which is a write back state. Otherwise, it just transitions back to a fetch state. If it is a load instruction, it has the write back state and executes, transitions back to the fetch state. And as you'll see in the schematic, there's 2 controllers. There's a state machine based controller unit, and there's also a decoder based controller unit. Essentially, the decoder handles all the selects associated with instructions, essentially controls the muxes, everything else. The state machine controls the micro operations, which controls the loads, etc., etc. And we will move on to our last thing here. And once again, most instructions are 2 clock cycles, and the load instructions are 3 clock cycles. So roughly speaking, we go get the instruction, we decode it, see what it is, send out the right control signals. But for that load instruction, we are also for one of the things we do in the load instruction for the execute cycle is calculate effective address, and we use that effective address to access memory, which is synchronous, which is why we need that write back state. And so the result of that write back state, these load instructions are going to be from going to take from memory to a register. The result of that in the write back state is it's going to turn the write enable on for the reg file, and you'll see that coming up. And so so once again, real important here. The load instruction is going to use the ALU to calculate an effective address, And if you remember, the load instructions look something like this. So this is the base address, this is the offset. It's going to add these two values up. So here comes here's the base address, here is the offset, it adds them. Your result comes over here to the memory. The next clock cycle comes around. So this all happens in the execute cycle. Next clock cycle brings it to the write back cycle. And that write back cycle, it's going to output the data it needs to put into the RAM, and all the selections are going to be made such that all the appropriate data goes into the register file. And that is all for this lecture. We're going to hit the timing diagram here.